This problem is from the 2025 Harvard-MIT Math Tournament. Feel free to give it a shot and keep watching to see the solution. Okay. With these kinds of problems, there's usually more than one way to solve them. I'll show what I did. I'll show two solutions, one with Trig Sub and another one with factoring. But if you have another approach, feel free to share it in the comments, because I want to encourage discussion on these videos. Okay, so first, why would this be a trig sub problem? Well, if you see something squared plus something squared, you can think of this, a squared plus 1 squared, right? Something squared plus something squared. Then it should remind you of the Pythagorean theorem, and this is why you want to consider trig sub. Okay. So what should we substitute for A? What trigonometric identity has a trigonometric function squared and 1 on the same side of the equation? Well, there's tangent squared x plus 1 is equal to secant squared x, and there's also cotangent squared x plus 1 is equal to cosecant squared x. So our possible trig substitutions would be A is equal to tangent x, or we could do A is equal to cotangent x. So let's try them out. We could try out both and see if there's one we like more than the other. Okay, so let's try this out. So if A is tangent x, then it's going to turn into 2 times tangent squared x plus 1 is equal to 3 times. I'll define B and C similarly. B is equal to tangent y and C is equal to tangent z. Okay, so that would be tangent squared y plus 1 and 4 times tangent squared z plus 1. Okay, and this is just going to turn into 2 times secant squared x is equal to 3 secant squared y is equal to 4 secant squared z. Okay. All right. Let's see here. So secant is the same thing as 1 over cosine. So let's try to rewrite this in a different form. I don't see anything that can really help with solving the problem here, but okay, let's see if writing it differently will offer some insight into solving it. Okay. Yeah, so this actually looks kind of similar to the law of sines. If we were able to change this into sine, 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 then we'd also be able to do what? Since these are positive real numbers. We could take the square root of this entire thing. Okay. So, yeah, if we wanted to change this to sine, we could use the other identity. So let's go ahead and do that. A is equal to cotangent x, B is equal to cotangent y, and C is equal to cotangent z. Okay, so if I were to make that substitution again, we would end up with 2 over sine squared x is equal to 3 over sine squared y is equal to 4 over sine squared z. Yeah, and then we take the square root of the whole thing. So root 2 over sine x is equal to root 3 over sine y, which is equal to root 4. So that's just 2 over sine z. Yeah, so now we can consider a triangle with these as side lengths, but we need to make sure that this also holds. So if we make this trigonometric substitution, is this going to be true? Let's double check. So yeah, with this, x, y, and z are the angles of a triangle. So yeah, let's see here. So basically, if x, y, z are angles of a triangle, then we have x plus y plus z is equal to pi radians, and we have, okay, so we make the trig sub here, so cotangent x times cotangent y plus cotangent y times cotangent z plus cotangent z times cotangent x. Is that going to be equal to 1? Well, let's see here. So, let's see. This is going to be 1 over tangent x times tangent y plus 1 over tangent y times tangent z plus 1 over tangent z times tangent x. And we need to get a common denominator. Okay, so the goal is to show that this is 1. Let's get a common denominator. It's going to turn into tangent x plus tangent y plus tangent z over tangent x times tangent y times tangent z. And yeah, if x, y, and z are angles in a triangle, then this is going to be equal to this. So it's equal to 1. How do I know this? Well, I made a video on this. Yeah, watch my previous video. But yeah, basically, if you have angles of a triangle, then this is equal to this. Okay, so then that means this trig sub works. Let's go back. Let's go back and see how we're going to finish the problem. Okay. So we're going to draw out the triangle. Okay, root 2, root 3, and then 2. Okay, and then let's see here. X, Y, Z. Okay, and what do they want us to find? They want us to find a plus b plus c. So that's going to be cotangent of x plus cotangent of y plus cotangent of z. Here, find cotangent of x plus cotangent of y plus cotangent of z. To finish off the problem, we can use the law of cosines to find cosine x, cosine y, cosine z. And then we can use sine squared x plus cosine squared x equals 1 to find sine x, sine y, sine z. And then we can get cotangent x, cotangent y, cotangent z. Okay, so let's go ahead and do that. Okay, so the law of cosines, that means x squared is equal to y squared plus z squared minus 2yz times cosine of x. So let's go ahead and plug these in. So root 2 squared is just 2, and then it's going to be 3 plus 4 minus 2 times, so yeah, y is root 3, and then z is just 2. But I'll leave it as root 4 because it'll make working with the radicals a little bit easier. And now we need to get cosine x by itself, so it's going to be 2 minus 3 minus 4 over, okay. And then, what's cosine of y? So it's going to be, let's see here. 3 would be on the left-hand side. Minus 2 over 2 times. Let's see. So it'd be zx. Z is root 4. And then x is root 2. Okay. Maybe I shouldn't have... okay, I should have left the square roots. Yeah, okay, I didn't do anything bad. Yeah, leaving the square roots, that way I know that these represent the sides. 4 minus 2 minus 3. Okay. 2 minus 3 minus 4. Negative 5 over. Let's see here. Let's just rewrite this as negative 5 over root 48, because this will make it easier when we draw out the triangle. Okay, negative. This is going to be negative 3 over. Well, let's see here. No, this is just positive 5 over root 48, and this is just positive 3 over root, let's see here. 4 times 2 times 4 is 32. And then this one's going to be 1 over root 2 times 3 times 4 is 24. Okay. So now we need sine x, sine y, sine z. Okay, so cosine x, let's draw the triangle. So cosine is adjacent over hypotenuse, so hypotenuse would be root 48, and then, let's see here. Yeah. So we'd do 5 here. So that means this would be root 23 by the Pythagorean theorem. So that means sine of x would be root 23 over, over root 48. How about sine y? What would that triangle look like? Okay, let's see. Root 32 for hypotenuse. And then this would be 3. Okay, so 32 minus 9. 32 minus 9 is 23. Let's see what goes in the over root 32, and then sine z. Okay, root 24. This would also be root 23. Root 23 over root 24. Okay. Let's try to be a little clean here. A little bit cleaner here. Okay, I'm gonna get another sheet. Okay, so that means, okay, what's cotangent x plus cotangent y plus cotangent z? Well, that's going to be cosine x over sine x plus cosine y over sine y plus cosine z over sine z, which is going to be equal to, okay, so 5 over root 48 over sine x, so root 23 over root 48 plus 3 over root 32 over, let's see here. Yeah, root 23 over root 32 plus 1 over root 24 over root 23 over root 24. Okay, so this is going to be 5 plus 3 plus 1, so 9 over root 23. If you rationalize the denominator, it's going to be 9 root 23 over 23. This is your answer. Okay, and here's the solution with factoring. So you'll notice that they gave us a squared, b squared, c squared, as well as ab plus bc plus ca, and they want us to find a plus b plus c. Well, what factorization has a squared, b squared, c squared, as well as ab, bc, and ca that's related to a plus b plus c? Well, it's going to be a plus b plus c squared. So if I square this, then we're going to have, it's going to be a squared plus b squared plus c squared plus 2 times ab plus bc plus ca. And, well, they gave us ab plus bc plus ca, but we can get a squared, b squared, and c squared by themselves as well. If we set this equal to x and then solve for a squared, for example. You'll also notice that we can plug this into here and factor. So a lot of factoring going on. It's probably worth it to explore the solution path. So let's go ahead and do that. Okay. All right. So yeah, as mentioned earlier, if we set this equal to x, then we can get a squared by itself. So a squared is equal to x over 2 minus 1. And then by a similar process, we can get b squared is equal to x over 3 minus 1. And then c squared is equal to x over 4 minus 1. Okay. Now, if we wanted to get a plus b plus c squared, and that would be a squared plus b squared plus c squared plus 2 times ab plus bc plus ca. And if we can find this, we can take the positive square root, because well, in the problem they mentioned that it's a solution with just positive real numbers. Okay. Yeah. So let's go ahead and plug all these in. So x over 2 minus 1 plus x over 3 minus 1 plus x over 4 minus 1 plus 2 times 1. So just plus 2. And this plus this plus this is going to be a half plus a third plus 1/4 is 13 over 12. Okay. So that's what a plus b plus c squared is. But what you'll notice is, as mentioned earlier, we could also, we didn't try plugging this in for 1 in factoring. So, and if we factor, we're able to get a plus b, b plus c, c plus a by itself. And if we do that, then we can square a plus b, b plus c, c plus a, and then subtract however many times this we need to get some multiple of a plus b plus c squared. It's a lot of steps ahead, so okay, I'll just show you guys. All right, so if I plug this in for 1, it's going to turn into 2 times a squared plus ab plus bc plus ca. And this is factorable. So it's going to be 2 times a plus b plus c times a plus b. Okay, and then we can just take this out. Okay. All right, so yeah, this is going to be equal to x, but I'm going to do a plus b times c plus a is equal to x over 2. We'll do this with the other equations, and I'll explain why in a second. Okay, so the next letter, yeah, so to go from A to B, you just go to the next letter. So go to the next letter. After C, cycle back to A because there's no D. Okay, and then c plus a times b plus c is equal to x over 4. Okay. Yeah, so the reason why I got this by itself is because, well, if we get all these by themselves, we can multiply these equations together, take the square root, and then divide out this equation to get b plus c by itself. Yeah, basically this is a pretty common setup in contest math, and if you see it, you're able to get like this by itself, and this by itself, and this by itself. I'll show you like real quick. So yeah, if we multiply everything together, we're going to get a plus b squared times b plus c squared times c plus a squared is equal to x cubed over 24. And since we are dealing with positive real numbers, positive real solution, we can just take the square root of both sides of this equation. Positive square roots, c plus a is equal to x to the power of 3/2 over root 24. Okay, and then we'll just do this divide this equation into this equation. So this divided by this. Okay, let's get another sheet. Okay, so I'll leave this up here because well, we gotta keep our eyes on the ball. We're looking for another way to write a plus b plus c squared in terms of x. Okay. Here we are. Okay. So yeah, this equation divided by this equation. So this divided by this is going to give us b plus c is equal to this times 2 over x. So that's going to be root x over 2 root x over root 24. Okay, and then c plus a is missing on this side, and then it's going to be this times 3 over x. So let's see here. 3 root x over root 24, and then what's missing is a plus b is equal to 4 root x over root 24. Okay, cool. Yeah, so another way we can get, as mentioned earlier, another way we can get a plus b plus c squared is we can square each of these to get rid of the radical, and then subtract however many multiples of ab plus bc plus ca we need to get a multiple of this. You might be wondering, can we add all these together? Divide by 2, subtract out the equations to get a, b, and c by themselves. And you can try that, but it's going to be very troublesome because, well, okay, I can show it here. Well, it just gets, let's see here. It gets a in terms of x, b in terms of x, and c in terms of x, but it doesn't exactly solve for a. It doesn't exactly solve for b, doesn't exactly solve for c. It doesn't give you the exact values, so it doesn't really help. But yeah, so eyes on the ball. Let's try to express this in a different way by squaring these equations. Okay. So a plus b squared plus b plus c squared plus c plus a squared is equal to it's equal to 2 times a squared plus b squared plus c squared plus 2 times ab plus bc plus ca. Okay. So basically, if I add 2 times ab plus bc plus ca to both sides of this equation, then I'm going to get 2 times. Yeah, so let's add 2 times this to both sides of the equation. Okay. Yeah, so the reason for adding 2 times this to both sides of the equation is to factor this as this. So we can get it to look like this. And then we'll divide both sides of the equation by 2. Okay. Is equal to a plus b plus c squared. Okay, and then we'll just plug these in. So, yeah, okay, it doesn't matter in which order we add these. But if we square this, it's going to be here. Let's just do it like this. B plus c squared is equal to 4x over 24, which is equal to x over 6. And then c plus a squared is equal to 9x over 24, which is equal to 3x over 8. And then a plus b squared is equal to 16x over 24. So divide by 8, so 2x over 3. Okay, so this is going to be x over 6 plus 3x over 8 plus 2x over 3 plus 2 over 2 is equal to this. Okay, so we need to add these fractions, but be careful. Let's see here. Okay, we'll do them here. Okay, so 1/6 plus 3/8 plus 2/3. That's equal to how much? Least common multiple is 24. 4 plus 9 plus 4 plus 9 plus 16. We should have never reduced these. Huh. Okay, 4 plus 9 plus 16. 29 over 24. Okay, so 29x over 48 plus 1. That is going to be equal to let's see here. That's equal to a plus b plus c squared. Okay, so that's equal to 13x over 12 minus 1. Let's get another sheet of paper. Okay, just a sec. Yeah, so we got a plus b plus c squared is equal to, let's see here. Okay, so just copy this part. 29x over 48 plus 1 is equal to 13x over 12 minus 1. Okay, so this is going to be equal to 52x. Okay, subtract. Okay, so 2 is equal to 30. Oh, wait. Be careful here. 23x over 48. So x is equal to 96 over 23. But that's a plus b plus c squared. Sorry. So if we plug this in here, we can get a plus b plus c squared. Yeah, this is x. Yeah, so let's just plug this back into this to get a plus b plus c squared, and then just take the square to get a plus b plus c. Yeah. This is going to be our answer, but let's simplify. (104 minus 23). Let's see, 81 over 23 is equal to 9 over root 23, which is equal to 9 root 23 over 23. This is your answer.